December 2005, a Soyuz from Baikonur successfully launches GIOVE-A. This satellite was essential to secure the frequencies allocated for the Galileo program. With GIOVE-A in orbit and the frequencies secured, Galileo could move forward. In 2008, GIOVE-B was also launched from Kazakhstan. It was the first satellite to carry the European-developed maser atomic clock. This extremely stable atomic clock is now standard on all Galileo satellites. But 10 years ago, it was the most advanced clock ever flown for navigation purposes. The excellent test signals sent out by GIOVE-B were a prelude of what was yet to come. In 2011, the first complete Galileo satellites were launched. And by October 2012, ESA had 4 satellites in orbit. This is the minimum of satellites needed to determine a position, and ESA could start with the so-called in-orbit validation phase. On the 12th of March 2013, the historic first position fix using only Galileo satellites took place. The system was validated in orbit and worked well.
The quality of the signals from the Galileo constellation is very good. We have measured our signals with the signals coming from other systems like GPS or the Russian GLONASS and the Chinese Beidou. We know that at the moment our signals are among the best, so we're very proud of that.
In parallel with the construction of the space component, ESA was building a ground segment with 2 control centres to guide the satellites and disseminate the signal. One was built in Oberpfaffenhofen, Germany, and one in Fucino, Italy. At Europe's Spaceport in Kourou, dedicated facilities are reserved for the deployment phase. During the last couple of years, ESA built and launched Galileo satellites in record time, using both Soyuz and Ariane 5 launchers. Now ESA is launching a 3rd and final Ariane 5 with another 4 satellites.
With this we will have 26 satellites in orbit, 2 of which are in an elliptical orbit, which despite a slightly wrong orbit we can still use. One of the satellites is a reserve and another satellite is faulty and we cannot completely use it. So we will have more or less 24 satellites operational in orbit, and this is what the desired minimum is for full operations.
With the constellation up and running, the European Space Agency will further expand the ground segment in the years to come and launch more satellites, either as spares or as replacements for the older satellites. Starting in 2025, Europe will have a new and improved generation of Galileo satellites ready for orbit. Despite ESA going from a satellite navigation novice to expert in 15 years, the design and services of this second-generation system will be very much market-driven.
The market is, of course, a very important point for us because although in the beginning one could argue that this was very much a market which was pushed by technology and, if you want, by us, the market is now developing so fast and is going to be so enormous that we have an incredible responsibility. The market has expectations. They want us to come with new features. At the same time, they want to be capable to do the things they have done. They don't want unnecessarily to replace their equipment. So we need the legacy services to continue while we introduce new features.
A market that is booming. Industry, agriculture, rescue services, governments are all reliant on satellite navigation. And with the newest smartphones, which are Galileo ready, even the general public has this technology literally in the palm of its hand. With Galileo, Europe now has its own fully operational satellite navigation system, at a time where the importance of navigation services is only increasing.